Before we jump into the presentations, some info about the agenda for today's session. So for today, we're going to have this brief introduction done by me. I'm Madeira Scauri, Communication Dissemination Manager from Resurfaces. So happy to have you all here in this session. Then we're going to have a presentation from the project ALFAwetlands, followed by Resurfaces, REWET, and Wet Horizons. And then we're going to have a wrap up and next session will actually some like follow-up discussions for the end of the webinar, which will be also done by me, and the final feedback questionnaire that will be presented to you by my colleague Irina. Okay, perfect. Thank you very much. Next slide. Okay, so before we jump into the presentation, we start with the ALFAwetlands presentations from leaves to litter, measuring above ground carbon inputs and losses in wetland soil. The presentation will be made by Jyrki Jauhiainen. Jyrki is a researcher at LUKE, the Natural Resource Institute of Finland. He's a long-standing soil and peatland researcher specializing in GHG fluxes, peat ecosystem dynamics, and climate-resilient water management from boreal to tropical regions. Sorry. So Jyrki, the floor is yours. Thank you.
Thank you, Madeira. Good morning, everybody. Okay, let's start on the presentation. Next slide, please. Okay, we have been building to be short first. We are building a kind of a guidance for measuring litter inputs, litter decomposition on wetland soils. And the background for this is that wetlands are really large carbon stores, and they are very dynamic in sense of inputs and outputs. There's climate change, there's hydrological changes driven by people, there is a land use change towards draining, and more and more, luckily these days, also towards rewetting, which change the plant vegetation on these sites. And to get a real accurate understanding of the carbon balance in soil, we need both to measure the losses and the inputs. And these may be changing from year to year because of the climate, hydrology, and various reasons. And often these numbers are about equal size, differing not that much, the inputs and outputs. Okay, next slide, please. So, and most of the most common studies made on soil carbon balance are being made by chamber greenhouse gas flux measurements combined with the litter carbon inputs. And here it's because these sites are often remote and there are no advanced ecovariance and other technologies available, and those are very expensive. So cheaper methods are being used. Next. So for what we know about these greenhouse flux measurements on the gaseous form, these are being quite well established since 1980s. There are a number of studies, and I think, and what I've learned from assessments to this data, the data collection has refined itself over the years. The bad methods and the bad kind of ways to do measurements, they've been kind of brushed off over the time, and more higher quality studies are being accepted by journals. Whereas, next please, the litter and root dynamics forming the soil carbon inputs are far less documented in the literature, and they are kind of in some times they've been forgotten, and the people tend to work towards the emission side and not really looking the balance in the soil. So the numbers often are borrowed, or they are just measured once, or they are just nowadays no longer it's been provided soil carbon balance based on emission side only. So our next please. So this is a problem because the data collection on the litter inputs and the composition side, it's poor. And so this weakens the compatibility between different studies and the results. And so there is a space for getting kind of a guidance. And I'm not saying that we are building a guidance to be adapted by everybody, but guidance to lean on when you're planning the work to be done. So the idea is to improve the data to be used in soil carbon balance studies. And now that's the major limit is for like a IPCC process and so forth. The weak side is on the litter, the mass material inputs and losses in soils, including wetlands. Next, please. And as we know, wetlands are very diverse. Some are drained, some are full of trees, some are a mixture of trees and ground understory vegetation and ground vegetation, mossy. Some are patchy with water and soil, open soil. Some are full of mossy. Some are growing. There are evergreen species, annually deciduous species. There are species which are disappearing every year during the winter time and cold period. How to get kind of tackle this situation if you are a student or starting researcher. So the guidance is working towards that direction. Next, please. So our objective is to focus on the understory and ground vegetation biomass and biomass production and litter inputs, including woody debris from the trees. Trees are not excluded from the study, but we are trying kind of putting a kind of smaller emphasis on that side. And look also the above ground litter decomposition. We are not looking the below ground processes because these are recently discussed by Freshet et al. 21 paper. So we are looking to the above ground processes. And so the idea of the guidance we are building now is towards flexibility on various vegetation community structures, reasonable sampling effort. We are trying to minimize the kind of no repeated measurements because there are a lot of guidance for specific plant species and a lot of work to be done. But this is a kind of a trying to form a kind of a one-time sampling effort and the laboratory work as when it's possible. But of course, in some times, like litter inputs, you have to monitor over the kind of a repeated field visits, and some species like mosses, you need 1 year to collect the data, but the guidance will be provided. And foundation of this work is based originally on field guidance in 2 projects, Life Orkbalt and now in ALFAwetlands. And we are expanding the guidance from our conditions from boreal to temperate zone to kind of different conditions. We are trying to do our best to do that in a kind of a way that people can lean on the guidance when they are working. Okay, next slide, please. And when we started, the difficulty for me was that looking out from the box, from my familiar environments, and when we're building this manuscript, and here we actually, it was kind of relieving. Just before Christmas, I just stumbled on Slowey et al. Work where the plant growth forms and the plant functional types were assessed, and we found that okay, we are very close to that kind of a approach to this kind of a litter inputs and biomass collection methods. And okay, that's great. And then we combined that with kind of a technical kind of a vegetation stratification, trees, understory, and the ground vegetation components, which may be useful for people who are not that familiar of species and how they are, just technically dividing in different heights and combining these in the guidance. And yes, next slide, please. And here, this is a very small here, the text, but basically, we are combining the vertical structure and plant functional types, shrubs, graminoids, forbs, ferns, and mosses, how to get the biomass data, which can be divided into the annual growth and biomass production in a kind of an easy way. And the sampling is basically for mostly for one-time sampling event in the peak biomass time of the year, maybe August, late July, early September. And that's enough for the field work in most cases. Litter deposition is monthly measurements if there are trees present on the sites, and the litter decomposition, that takes over at least minimum of 2 years, but the guidance for running through this work is provided as well. And of course, sometimes you want to repeat the litter data collection over the years. We provide also guidance for making easier measurements next year, kind of making a models for the plant growth, and that might be useful as well. Next slide, please. And this is again from kind of a summary table of one part of the work. On the left-hand side, you can see there is a kind of a how we divide the vegetation in kind of a looking the proportions of different plant functional types, graminoids, forbs, ferns, mosses, and shrubs on the side. Also, we provide different kind of ways to do how to make the sample into the kind of a plots establishing and what is the kind of a fair minimum for doing this work. And then sampling from each plot that we will collect the shrubs. They will be collected. There are two methods for that: sampling the whole sample plot, which in our case we just provide kind of a 30 by 30 centimeter plots, but that can be adapted to the conditions. Collecting all the biomass from the monitoring plot, or by representative samples of each species found there for the shrubs. There are not that many shrub species, so we are looking to shrubs on species wise, and divided by deciduous shrubs, evergreen shrubs, and for methods for getting the kind of a biomass and biomass production in both conditions. Evergreen shrubs are quite tricky because they shed only part of the leaves annually, so we try to develop a method for assessing that as well. Graminoids, forbs, and ferns, it's just clearing all the material from the sample plot and process that later in the laboratory. For mosses, sphagnum, and other moss types, forest mosses, brown mosses, we provide guidance on that as well. And laboratory work provided, and trying how to fraction the samples and how to scale up to produce the biomass on the plot, biomass production, and so forth. And the same applies also for the litter samples, of the litter decomposition samples. So I'm taking time already too much. So next slide, please. Thank you for your attention, and I'm happy to. This is only a fraction of the work we are compiling now, but kind of giving examples what we are trying to do here, and I hope that this will be useful for starting new scientists and maybe also for more advanced scientists to further develop in the next coming research work. Thank you.
Thank you very much for your presentation, Jyrki. Now the floor is open for questions, so please do not hesitate to share your questions in the chat. Let's give it a moment. Do not hesitate to ask any information or like to deepen a little bit your understanding of this very good presentation. Meanwhile, while we wait for the questions to arrive, I would ask you on my side, what has been the hardest part of compiling this work?
As I already kind of gave a kind of a hint, it was looking out from the box. My familiar environment that's been a kind of in boreal context, that has been kind of a trained forested sites, looking also the open sites, and that has been in ALFAwetlands especially. We are kind of a number of different site types included, and our colleagues in the project have kind of put insight on that. And so they will be a co-authors on further developing this. So, and structuring, kind of putting, not just guiding, do this, do that, but kind of providing kind of guidance where you can, okay, if I'm in this condition, and my site looks this, how to go further and how to tackle with the different kind of vegetation and plant types there, and getting kind of a coherent sampling and calculations out from that.
Okay, perfect. We have a question in the chat for you.
Great.
So it's from Anna. How do you count for plastic or other human-made litter on the plot if you find any?
Okay. That's interesting. I didn't thought of that, but certainly that could be kind of considered as a one type of vegetation in a quotation marks. So if there are on the sampling plots, there are this type of litter available, it can be counted. Looked by the area and the number of species, like a individual plants there, or they're looking the cover percentage, and that's I think it can be included. I think the guidance can be modified, looking also man-made kind of into products on the plots. It can be considered in the planting in the sampling scheme. That's great. Nice. Thank you.
Perfect. Thank you very much, Jyrki. I think we have to pass to the next presentation because time is always tight.
Yes,
but in
thank you.
case
And
you have
everybody is welcome to send me emails and asking questions,
exactly,
because that
and
can improve the manuscripts. We are
please,
still
exactly, do so, and do not hesitate to pass also in the chat if you have more questions for Jyrki. We'll be very happy to pass them on to him and to have him answer. Thank you very much for your presentation, Jyrki. So now we go to Resurface's presentation, interactive platform and toolbox, which will be delivered by my colleagues Christoph Schröder and Anis Guelmami. Christoph is a geodata and GIS specialist at European Topic Center of University of Malaga. He's leading pan-European wetland mapping and assessment efforts, including Resurface's coastal wetland condition analysis and interactive platform, while Anis is project leader at Tour du Bala and a Mediterranean wetland expert coordinating the Mediterranean Wetlands Observatory and advancing EU-based monitoring, policy support, and capacity building across the region. So Anis and Christoph, the floor is yours. Thank you.
Yeah, thank you very much, Madeira. And yeah, thank you. It's a real pleasure to be part of this webinar series. And yeah, present from our side one of the key exploitable results that Resurface has produced. You know, the project has finalized already, so we're really having final results that we can present here. So, yeah, so as Madeira said, it's me, Christoph Schröder from the University of Malaga, and my colleague Anis, who will present this European Coastal Wetland Interactive Platform that was developed in the lifetime of the project. So for those who have maybe not been in touch with the or not involved in other or not participated in other episodes of this series, so Resurface is one of these sister projects that aims to evaluate the effect of restoration action on wetlands' ability to climate change, with a focus on one specific wetland type, coastal wetlands across Europe, which gives it this an added value on looking on one specific wetland type. The project, as the others as well, had different phases and worked first on data collection, data gathering across the different pilot sites. Then we aimed at upscaling this information, the findings to other scales in order to provide support also to wider scale policy questions. And finally, and this is where we come now to this key result that we are going to present, we wanted to integrate the information and data into a platform that can serve to access the information, but also to use the information for decision support. which ended up in being this European Coastal Wetlands Interactive Platform, the first, and as far as we know, only information platform and toolbox really only dedicated to coastal wetland ecosystems in Europe. A few words on the main goals and how we designed this platform. So in the first place, obviously, we wanted to facilitate the exploration and discoverability of the information, particularly of spatial explicit data on coastal wetlands. There's also, just as a side note, a data catalog for non-spatial spatially explicit data that is hosted at LiveWatch ERIC. But here we're looking particularly at spatial layers, spatial explicit data on coastal wetlands. The second goal was to provide access to consultation of spatial indicators that had been developed in the project. I'll come to this later, through targeted and comprehensive interactive dashboards, so that the results of these indicators not only are available through our reports and deliverables, but also in an interactive way accessible for the users. And finally, we wanted to support the spatial prioritization and identification of restoration actions across European coastal areas through also another set of interactive tools, which, as I mentioned before, was implemented in this platform. And let's go through a bit the different functionalities. We have put this not in a live form to ensure that we don't have any technical hiccups, but we have kept it to these slides. I think we will share the link in the chat in a minute, so you can also then explore the platform on your own. Just a few words. Okay, we have the part of interactive tools. Interactive tools to access and interact with indicators that we have developed in the project. One was related to policy indicators, where we did a proposal for monitoring policy processes across space and time, which can be accessed, and a few of them can be accessed through this policy progress indicator dashboard. And the other dashboard interactive tool relates to a major output, which is the assessment of extent, state, and GG profiles of European coastal wetlands, where all the final indicator layers are available for exploration in this dashboard. Let's jump into it and see what is in there for you. So for the policy progress tracking tool, as we called it, you can access the indicators and metrics that are currently available. Not for all indicators, data are available at a pan-European or European scale. So we're not able to have data for all countries and for all Europe, but the ones that are available can be accessed. Countries and wetland types can be selected, and statistics are summarized as well. And the same holds true for the external condition indicator tools, where we have listed, and here we have data for all indicators that were used in the coastal wetland assessment, both the direct drivers and the condition indicators, where also you can select the countries, go check different wetland types, and access and also download the information, the results and statistics of each of the indicators. Finally, the backbone, obviously, of every spatial data platform is the data catalog, where all spatial layers that have been produced in the project are available and accessible, and also downloadable as part. For instance, one key, I think, spatial layer that I wanted to also highlight is this wetland use intensity that was produced both for the 6 pilot cases and for the whole European coastal areas. So that would be all from my side, and I would hand over to Dennis.
Thank you, Christoph. So following the presentation on the platform, I will give a short introduction and overview of the decision support toolbox, which is also integrated within the platform. So before Jumping into the toolbox, just a few words about the conceptual approach we have used to develop this decision support toolbox. So as Christoph was mentioning, it's a tool to spatially prioritize wetlands for restoration, and we've been focusing on two main approaches. One is to highlight the needs for restoring existing wetlands, degraded existing wetlands, by integrating several data, like for example, the wetland extent, land use, land cover pressures, surface water dynamics, etc. And also we have been looking at the lost wetland that have been converted into other type of land uses, and this was developed through the mapping of potential wetland areas combined with the current land use, land cover information, and then we assessed the effort needed to recover or to regenerate these lost wetlands with restoration efforts. And yeah, so this has been also integrated into framework with the prioritization by adding, for example, the information on the key biodiversity areas, ecological corridors, protected protection levels, sea level rise, etc., in order to have better prioritization of the opportunities for wetlands restoration in coastal zones in Europe. And as I said, so this toolbox is now available within the platform. You can access directly using the link shared in the chat. There are several components, so 4 main components. The first one is on the ecological relevance, so enables the identification and delineation of European coastal wetlands and their classification using a hybrid classification system combining Korean land cover with Ramsar definitions. Then you can also find within this interactive toolbox information on this spatial delineation of the potential wetland areas and an assessment of the effort needed to restore the lost wetlands. So all the wetland habitats that have been converted into other land uses, as well as additional information on the level of pressure for all coastal wetlands. So you have these pressures analyzed with a comprehensive way at the scale, at the pan-European scale for all coastal wetlands, as well as the protection level for all these wetlands based on the data available at the European and the global scale. And we have also, as I said, integrated some information on the ecological relevance, so where to restore wetlands in order to improve the biodiversity and also the ecological corridors. For example, we have integrated here the key biodiversity areas and also other information on the ecological corridors to highlight the priorities, the spatial priorities, and to help the decisions at the local scale. So all these tools are available, as we said, now online. You can access to the platform and navigate through the different map viewers and indicators that we have provided. So if there is any question, please do not hesitate to ask, or also to send us emails to Christoph and myself. Thank you very much.
Thank you, Anis, and thank you, Christoph, very much for this presentation. So now we open the floor to questions. Do not hesitate to pass your questions in the chat, and I will be very happy to share them with our presenters. Meanwhile, once again, a question from my side, given that like the toolbox that has been developed for surfaces, we always talk about the sustainability. So how do you envisage like the future and the sustainability of this platform?
Sorry, I had a shortcut in the connection.
No worries. Should I repeat the question?
Yeah, briefly. Yes.
Okay, perfect. So I said, like, given the fact that, like, we're giving, of course, much importance to the sustainability of the outputs of European projects and so on. In this case, how do you envisage the future and the sustainability of the platform developed within Resurfaces?
Yeah, thanks. I mean, this is always a discussion, and this was also part of our discussion how to set this up. We opted for linking this or embedding it, and if you access the platform, you also will see some icons there to further click on to have it as part of a wider data platform that we host at the University of Malaga. And so when it comes to the infrastructure, when it comes to data and content, we're working very closely still with the colleagues from Tudi Balat and other project partners in order to keep the data as updated as possible. So as I said, for some parts there are even parts of the data that are not available so far, that we hope to get and update these parts to possibly, when further assessment is happening, also to update the indicator part. So the idea is to keep not only the infrastructure running, but also the results being updated. And that maybe as a second part linked to that, also to try to link this platform in a way, because we are focusing on coastal wetlands. There are many other platforms around wetlands available or emerging. So to link this platform also to other platforms in order to be an entry point for this specific wetland type.
Perfect. Thank you very much. We have two questions in the chat for you. The first one is from Lorenzo. Who is the end user of this platform, and how did you determine and implement the different levels of accessibility during its development?
Can I answer, or you want to?
Yes, one of you, please.
Thank you, Lorenzo, for the question. So the end users of this platform are both we are targeting decision makers, but also technical staff from the different stakeholders working on wetland conservation at general. So wetlands conservation, including management, wetland management, and restoration. So there are several level of information that they can use. Some indicators related to the policy and the way to integrate data into wetland management could be useful for decision makers, and other informations are more relevant at the local scale, especially for people working on wetland conservation, for example, with the spatial prioritization, and also integrating several level of layers and information into this spatial prioritization. So I would say, policy and people and stakeholders working on decision making, but also technical staff working on wetland conservation at the local scale.
Perfect. Thank you very much. We actually have extra questions, so it's very good and interesting to see that the interest is rising towards the platform. So the next question is, have you also included any economic data, for example, different restoration costs? And this question comes from Nadia.
For the toolbox, we are now working, as Christoph was said, that this work is not finalized, and we are still adding new information, and it's an evolving tools. So for the moment, for the timing, we have integrated physical information for the prioritization, spatial prioritization, and also some models to integrate future scenarios, including future economic scenarios. So we didn't integrate yet the information related to the social economy into the decision support platform toolbox, but it could be something that we can do soon if the information is available at the comprehensive with a comprehensive way at the European scale.
Perfect. Thank you very much. I am afraid we are out of time. There are extra questions in the chat, but I see that Christoph is already addressing them. So thank you very much, Christoph and Anis, for your presentation. So once again, please do not hesitate to reach out to them in case you have any questions, also through their emails or also through the LinkedIn group. I'll be happy to make the link and share their contacts. Okay, thank you very much. We go now to the next presentation. So next presentation is by REWET. It's improving the information available for the management of natural areas and ecological restoration to make them resilient to climate change. The presentation is going to be delivered by Jaime Ribalaygua Batalla, who is president and founder of the Climate Research Foundation. Jaime is a climate and meteorology expert with 35 years global experience leading research and innovation on climate impacts across sectors and continents. So Jaime, please, the floor is yours.
Okay, thank you. Thank you very much for the invitation. Let me show you some tools that we have developed for this management of wetlands. We are applying it to other environments, but also can be applied for wetlands. Let me show you the results of this project for Esteco that was funded by the Spanish Fundación Biodiversidad with Next Generation funds, and we are the coordinators of the project, the Climate-Resilient Foundation. These are the partners. Very quickly, I just want to tell you the main objective of the project is to produce a WebGIS platform which provides information on future suitability of plant species at a local scale. And this information is thought to be used by managers to select the species which are resilient to future climate in each point. In this case, for wetland managers, they can use this platform to see which species will be suitable in the future climate for that point. Okay, so let me give you some key ideas regarding this development. The first one is that we are working in future climate, so we have to work with uncertainties. We don't know what will happen. We know what could happen. So to manage these uncertainties, we have to work with as much projections as possible. We have used 10 of the most famous or most reputed climate models in the world as established by the IPCC, with the 4 SSPs, socioeconomic pathways, that are selected by the IPCC in order to produce these 40 future projections that if they are very similar, that means that the uncertainties are less. If they are very different, uncertainties are bigger, and you don't have all the information to decide. So we have produced this future climate information from these more than 5,000 weather stations in Spain. We have then interpolated them to a grid of less than 1 kilometer. So we are working on this local scale because climate change will have different changes in local in points that are really close to each other. The second idea is the improvements we have introduced into the species distribution models. You may know how do these models work. They have the presence of a certain species, the presence of a certain species. We have the environmental factors of all the territory, and then we establish a statistical model, the species distribution model, that produces this potential distribution attending to the values of the environmental factors. So this provides areas with low suitability for this species and with high suitability. So we are going to calibrate these models with the observations and to apply it to the future climate. Okay, so regarding this improvement of the models, the most important thing is, of course, the input of the models, the environmental factors. We have used these 19 variables that provided by WorldClim, but it's important to know that these variables have abrupt spatial and temporal discontinuities that prevent their use, and that you have to be careful how to use them, because sometimes they cannot be used because they produce this discontinuity. So we have developed a tool to reduce this effect. I don't have time to explain to you, but it's important for you to know that you have to take care with this direct formulation of the word clean variables in order to avoid this problem. Another way to improve the species distribution model is to include information about the effect of shaded or sunny slopes of a certain point. And we have taken this into account with variables regarding evapotranspiration, but including the effect of topography on solar radiation that, of course, makes a lot of effect on the vegetation you can have in a certain point. So these variables have been also included for the species distribution model to select them, and this improved very much the reliability of the models. And this also is very important, that justify the work working with very high resolution. Climate information perhaps is not so needed to work in better resolution, but it's important to work with this high resolution to take into account this effect of very high detailed topography. And finally, we have also included other information regarding soil, so that of course affect plants. So the model distribution, the species distribution model, we have included all these word clean corrected variables, all the evapotranspiration and the soil variables, and this produces a very good result. Finally, we have also improved the species distribution model using a consensus model. We used 3 different types of species distribution model with 10 replicas each one, so we have 30 replicas, and from those we produce this consensus model that produces more robust, reliable, and stable results. Another key idea, the third one, the need of validation. Before using the information of future of whatever, you have to assess how does it work in your point of interest. Not all the climate models perform in the same in all the territories, so you have to assess, for example, in this case, the climate models, how are they performing in your point of interest? And of course, the species distribution model, we apply them to the current climate, and we see how do they reproduce the presences, the real presences of that species. So it's very important to, before looking to the future, to look how does this work in the past, okay? And the final idea I would like to point out is the use of ecological genetic groups. What is this? You see here you have the Pinus alepensis, is one species here in Spain, and we have 5 different ecological genetic groups. They have been divided by the administrations, the forestry administration here in Spain, and this population of Pinus has different ecological and genetic characteristics, so they are specifically adapted to this the environmental conditions of the area where they have been developed during centuries. So this Pinus is completely different to this Pinus. It's the same species, but has very different characteristics. And it's very important to work independently with each of the genetic groups. Because if you make a species distribution model with all the species without working with the different groups, you have these results. And as you may see, the red dots show presences that are not well simulated, and as you see, the presences that are on the sides are not well reproduced. So if you perform a model that mixes this Pinus with this one that are completely different, you got a lot of noise and you don't get a good performance. But if you perform the species distribution model only with the presences of the Pinus of this southern group, you then have a specific model that reproduces very well this kind of pinus. Okay. This is very important because in many places we have results that, for example, in this area, you have a certain genetic group, but in the future, this genetic group will not be adapted to future climate. But the group from another side, normally in the south, a more southern group, is adapted to the future climate for this area. So the manager can use this other group without changing the species, without changing the landscape, and this group is adapted to the future climate, while the present group is not. So it's very important to make this, and this is one of the key ideas of the development we have done. Let me show you very briefly the platform we have developed here in Spain. It's called Foresteco. You can access it here. It's only for Spain, of course, but it has information for 50 species, 50 most important species, and some for 12 of them. We have these genetic groups or ecological groups different for each species. So we have almost 100 items that are projected in the future. And the tool has two different options. It has many facilities, but we don't have time to go through. Two mainly options to try to access to the information as an aerial information. You are interested in a whole area, and you can make it has tools to make this kind of maps with the information for the present and for the future, for the three periods, beginning of the century, mid-century, and the end of the century, and for each of the SSPs of the scenarios of greenhouse gases emissions, and for the species you want. So with this, you can see where are how will evolve the suitability of each species. And the second one is if you are interested in a certain point, for example, in a wetland, you can just press in that point, and the model and the system will go into all the information and provide you with this Excel that provides you with all the species sorted by the most suitable in the future, all the species that are suitable for that specific point, giving you all the information for all the period and all the SSPs, and much more information that can be accessed in the help of the platform. So you can this way select some of the species that may be of your interest for your certain point, and then you can go in depth in the platform to address these uncertainties. How does the different models predict that, and so that's what I have time to show you in these 10 minutes, but I am open to your comments.
Thank you very much, Jaime, for your presentation. I think that we already have one question popping up in the chat for you, so I'm gonna read it out loud. The question comes from Maud. Thanks a lot for your presentation. Do you have ecological threshold, for example, for soil parameters on the level of Europe? How did you define the conditions needed for the plant species? Did you consider regional differences? It's actually three questions folded into one. So I leave you the floor.
Yeah, well, I have shown this for Spain, but we have applied this within REWET project to the wetlands of REWET. So we have made the same methodology to apply. We have selected 70 species that were of interest of each of the open labs in REWET, and we have produced the future suitability for the open labs. So we have applied regarding, you mentioned the soil information. We have used a soil grid, that is a database that is available, I think, for the whole Europe, and we have used some of the information provided by soil grid. And regarding how I define the conditions needed for the plant species, well, it's the model that defined it. So you present the model this plant is here and here and here and here, and these are the conditions that you have here and here and here and here. And so the model says, well, this plant only can live when the temperature in summer is between 22 and 24, and when the precipitation is between this, and when the soil is like this. So the model performs this selection of which are the variables that are conditioning the presence of the species in the present, and then once you have calibrated this model with the real conditions observed in the last 30 years, you apply them to the conditions forecasted for the future. I don't know if I answer well the question. And regarding the regional differences, not only the regional, the local differences. You go into this detail. In this project, we work with a bit less than 1 kilometer. Now we are working in 200 meters resolutions in order to capture very well these kind of issues. For example, in Spain, we have a species that only lives in shaded slopes, and without taking into account this very high resolution, the models would say this species will disappear for sure. But when you take into account these very, very small areas that have some shadow and where the species can survive, then the model allows you to say, even in the future climate, here it could survive. So I don't know if I answered all the questions.
Thank you, Jaime. I think you have. And then as for the other presenters, of course, do not hesitate to share more information to address, let's say, the rest of the question. If you want to provide more details or info directly in the chat. So thank you very much. I'm afraid we don't have any time for other questions. So we will have to go through the next presentation, which will be delivered by Weth Horizons. Next presentation is GServiPeat, decision support tool, app for visualizing spatial data products. It's going to be presented by Marta Stachowicz and Alessandro Gimona. Marta is a peatland hydrology researcher analyzing drainage and rewetting impacts using field and remote sensing data within Weth Horizons. She's an assistant researcher at the Warsaw University of Life Science, while Alessandro Gimona is an ecologist, geographer, modeling climate-affected social ecosystems for carbon and soils to species and spatial planning, contributing to Weth Horizons. He's also like a senior landscape scientist at James Hutton Institute. So please, the floor is yours.
Hello, everyone. I'm really glad that I could join and present our tools. So these two tools were developed within the Weth Horizons project. And first, I would like to present the GServiPeat. Yeah, regarding wetland restoration, there are many questions that need to be answered. So, for example, how can peatlands be rewetted? How much will it cost? What can be the benefits regarding environment and also economy? What could we gain in return? Are there any alternative solutions? And can we see what could happen at a larger scale? So answering these questions is a starting point of the decision-making process. And please, next slide. And to answer these questions, we developed GServiPeat within the Weth Horizons project that could help solve these questions. So GServiPeat is an online tool based on multiple models, and it is a decision support system that provides certain estimates. So it estimates the recommended number of dams and their height in ditched peatlands in the scenario of their rewetting. We also get the information what is radius and area of rewetting influence, and now the expected outcomes like ecosystem services. And this includes water retention gains, changes in greenhouse gas emissions, nutrient dynamics, potential changes in biodiversity, and then we get the approximate estimation of ecosystem services. And additionally, we get the best management practices in different land uses that user selects. And please, next slide. So regarding the methods, even though the ServiPeat is quite easy to use for the users, it is quite a complex tool because it contains multiple models within the algorithm, and it has different modules. So first, it is based on the hydrological module. So we model how much we increase the water level in this scenario of peatland rewetting, and then we have to incorporate these hydraulics to calculate, for example, the spacing between the ditch dams, ditch blocks, and how high they should be. We also have to use the mod flow, which is the widely used groundwater flow model. And in the biogeochemical module, we incorporate land surface models that were also developed and upgraded within Wet Horizons. So we use OrchidPeat for greenhouse gas emissions, and we model CO2 and methane. And we also model nitrogen and phosphorus release, which accounts for a kind of consequence regarding peatland rewetting. The ecological module contains biodiversity, and that is based on bioscore model, also upgraded within the Wet Horizons project. And then we incorporate the economical module. Please, next slide. So the user workflow is very easy. It is partially based on a picture. So the user selects the condition of the ditch, the type of a peatland. He selects the number of ditches in the system, and then he needs to put some information about the geometry of the ditch. There are also other parameters, but I didn't have time to describe all of them. So please, next. And I will just briefly show you the case study of the Netherlands. So I put the average parameters of one of the peatland complexes in the Netherlands. So it is a fen with ditches in good conditions. So please, next. And the results of such a simulation gave us the result, which is we would need 29 ditch blocks to restore that peatland, which should be around 1 meter elevation. The radius of the rewetting influence would be around 22 meters, and also we get the area of rewetting influence. And next slide, please. And then we also get the information about the water storage, about the amount of nitrogen released and phosphorus released, then the value of ecosystem services, and this accounts for the water storage and reduction in greenhouse gas emissions, but then it is also deducted by the costs of water remediation based on the phosphorus and nitrogen release. And we also get a relative increase in the number of species. And seeing that the costs of this kind of restoration would be around 12,000 euros, and the benefits are around 5,500 euros per year. But yeah, this is per year, and the cost is one time. So you would have to multiply it by, for example, 40 years, based on the time that the ditch block can survive. So please, next. There are also other features, so the user can get their information about the possible rewetting costs. That they can also use the trade-off analysis and report, generate a report. And please, next. And lastly, how can we apply ServiPeat? So it can be used for preliminary planning and budgeting, and that can be also used for preparation of funding applications. The ServiPeat can be also used for cost-benefit analysis and communicating potential outcomes of such actions. So it can be like an ex-ante assessment of peatland rewetting. And I now give floor to Alessandro. So please, next slide, and I try to be as fast as possible. Thank you.
Thank you, Marta. Please, Alessandro, the floor is yours.
Yeah, so I'm presenting this tool, which is still in construction. It will be finished by the end of June. So I don't have it populated with all the final data, but I think it's what I'm presenting today. It's an illustration of the functionalities rather than final results of some analysis. Next, please. So the tool is essentially a rapid screening tool at the landscape or regional or national level regarding where to focus resources, essentially. And it is a simple multi-criteria analysis tool based on spatial data. And I would say that its typical target user would be policymakers and technical staff. And so this app allows you to load a series of criteria datasets. You can then inspect them visually. We will see later what I'm talking about. Then you can assign them relative important weights before combining them to produce a zonation. And if you want, you can then download the results and do further analysis in your own GIS software. Next, please. So, as I was saying, the map data must represent some sort of criteria for a certain purpose. In Wet Horizon, of course, we focus on restoration. So you would imagine you would have a number of criteria that pertain to that. And I want to stress that the app doesn't make a decision for you. It allows you to explore options. And that's why also we have adjustable importance weights, as you will see later. And the typical use is to understand where you could focus your resources as an initial screening. And then you could do much more detailed analysis with other tools, such as the ones that have been presented so far. Next, please. So here is the simple user interface you're presented with. There is a introduction tab that I'm not showing that explains how to use the tool. This is what you're presented with when you select some data sets. So you would browse to your data of interest and select which one to load, and then you would be presented with initially with some static plots, just to see that everything looks like it should. Next, please. And what I want to show with these two slides is that it can handle data both at the European level, as you've seen a moment ago, but also you can have data at the catchment or a regional level. So in this case, this is a catchment in northern Germany at 100-meter resolution. There is a trade-off in terms of computation. So unfortunately, this being a shiny app, it's very difficult to do computations for the whole of Europe at 100 meters, for example. So there is a trade-off between the extent of the area and the resolution. In practice, while here you see criteria that are essentially mock data, because as I was saying, the population of the app hasn't been completed, will be finished in June. But in practice, you would have criteria such as the average water table depth, areas that are affected by erosion. You might have burnt areas. You might have areas that are transformed to agriculture. So these are all candidate criteria for targeting restoration. Then you can combine them into one zonation according to the importance to it. So next, please. So the next screen is about inspecting the criteria layers interactively. You can zoom in and out, pan, do the usual kind of GIS function to inspect your data sets properly. You can see there are buttons there where on the top of the map where you can click on the button to select which layers you want to inspect. And the map changes obviously interactively. You can also, next please. So you can also zoom in accordingly and carry on your data inspection. This is all to help you basically understand whether your layers are adequate to the purpose that you want to use them for. Next, please. So then here is where the third tab, which is about multi-criteria analysis, comes into play. And that's where the sliders that are on the left come into play. So you can then decide which importance to level each of your data sets have. So, with the sliders there on the left, you can slide to between 0 and 1, 0 being no importance at all, and 1 being maximum importance. If you think that all your layers have the same importance because you're not able to actually decide, you can give everything importance 1, for example, or the same importance level, and then the multi-criteria analysis will be conducted on an equal footing, essentially giving the same weight to all your layers. But you can use the layers to explore interactively. So if you change the importance with the slider, next please, you can see that the map changes. So for example, in this case, when the sliders are moved, there's an area in Central Europe that appears more important, and the areas in Scandinavia appears a bit less important than before. That's just illustrative. So what this allows you to do is to explore the consequences of giving different levels of importance to different type of criteria that you might be considering. Next, please. Yeah, so you can see that again, changing the sliders changes slightly the map. Of course, the more criteria you have, the more change you might expect. Next, please. So, of course, we have to remind users of the usual caveat, i.e. that the quality, the interpretation of the results depend on the quality of the data that are used. But that's probably what most users of spatial data already know. And I think that's essentially all I had to say for today. Thank you very much.
Thank you very much, Alessandro, and thank you, Marta, for your presentations. Please do not hesitate to raise your questions. We don't have much time, but we'll be happy to address at least one question for our speaker. I will give it a little bit of time, and let's see if something arrives in the chat. If not, I have a question to Marta, I think. So the results so far seem to be in numerical format only. So do you have any plans to develop the tool to a spatial version?
Thank you for the question. We thought about this, but then it would make the tool much more complex, because then we would have to have an option for the user to input shape files or TIFF files, like raster files. So it can be done, but then the tool was supposed to be as simple as possible for different kind of users to use it. Not everybody can use GIS data, so for now we intend to keep it in this kind of format.
Okay, perfect. Thank you very much, Marta. I think we are good, and we're running a little bit out of time. So next slide, please, and thank you very much for your presentations. I take advantage of this moment to thank all the speakers that participated into this session 6 webinar. It has been a pleasure to listen to your presentations. So now we jump to the wrap up of this webinar. Briefly, we are glad actually to invite you and to see you in our upcoming, let's say, conferences or the events we will participate in. We have a few showcased there for you. So you are welcome to ALFAwetlands and REWET final conference that will be held on the 17th and 18th of September 2026. You can also find Wet Horizons and of course with the presence of the sister projects also at CERE conference in Brest in France from the 24th to the 28th of August 2026 and a little bit more let's say recently the LifeWatch Biodiversity and Ecosystem e-Science Conference, the BEES, in Plovdiv, Bulgaria from the 7th to the 10th of July 2026, where you will be able to find resurfaces. I take advantage of this moment to also underline, since LifeWatch is organizing the conference, that we are still open in our submissions to for abstract and thematic groups and so on are still open. So please do not hesitate to check also for this event. Might this be of interest for you? Thank you very much. Next slide, please. So before we jump to the final feedback questionnaire and I leave the floor to my colleague Irina, I take a minute to thank all my colleagues. So Irina, Corinna, Maria, and Lena for helping us and to support each other and working on this webinar series. It has been a real pleasure to work with you and also to organize this series with all our wonderful projects and speakers. So thank you very much. Before we once again wrap up the webinar, please do not hesitate to trace back our LinkedIn group. It will be constantly updated with more information also from the sister projects. And also don't hesitate to check our social media and websites, which are constantly updated. And also do not forget that the previous sessions from this webinar series are all available on the sister project's website and ALFAwetlands YouTube channel. So thank you very much for participating into this webinar series and this session 6. Irina, the floor is yours. Thank you very much to all of you.
Thank you, Madeira. First of all, I would like to add that our projects are still continuing, unfortunately, beside Restofo sister project, with whom we enjoyed cooperation as well. And I want to add that in ALFAwetlands, we are also working on the best practice for cost-effective restorations of peatlands. That will also be a tool in the form of the website, and more information about that will follow. Also, I would like to thank all our participants, because you also help us to shape our events and to define most interesting topics. And that's why we are still planning several events, and LifeWatch Eric also continue work on the wetlands restoration projects and communication about that. And that's why we would like to ask you kindly to fill out the final survey, which will first of all help us to assess this webinar and also to plan our further events. And we are still have something to offer to you for your attention and for your work with wetlands and with restoration. That's why you will get a link to the final survey now, and also via your emails, and we kindly ask you to fill out this short survey about this webinar and future events. With this, I would like to say thank you to all involved, to communicators, to our experts, and to our participants. And let's meet again in Wetland Restoration LinkedIn group and continue our cooperation there. Thank you.
Thank you very much, Irina, and thank you also to the organizers, speakers, participants. It's been a pleasure. And stay tuned through the Wetlands Restoration Group and sister projects, social media and websites. Thank you very much. We also had a schedule, so enjoy your 10 free minutes and see you soon. Bye.
Thank you. Bye.
Thank you very much. Bye-bye.